Yeah, everyone to know that the sessions are getting recorded. So, and the same will be handed over to the admins of this data consultancy. So, when you will be requiring, that should be updated into some of the YouTube channels of the same company's YouTube link. I'll be handing over the same stuffs at the weekend. So maybe by tomorrow I'll be handing over these three lectures. So whenever you require, you can just go ahead with those recordings. Somehow you missed it or somehow you want to recheck it, so you can check it from there only. Okay.
Okay.
So, but first of all, do you have any doubt from yesterday's classes?
No, from yesterday's classes, I don't have any doubt.
Okay. So yesterday's just to, it's a basic introduction of what is data and what kind of different representation the data can be. So we learned there the relational database and non-relational database. Today
Mhm.
we'll be just starting with relational databases only. As I mentioned that for the data analytics purpose, we should be mainly taking relational database. And for the non-relational database, as I mentioned, there is lots of applications as well in market and the present scenarios. Especially, it can be used as a web-based. Suppose a web wants to pull the data quickly from a database. So for that much faster response, people can choose NoSQL database. Okay. Suppose I am
Mhm.
just building a web interface and I want to pick the data as soon as possible from the backend system. So I can choose then that the database storage can be web. But especially for data analytics purpose, as we are been doing the courses for data engineering and all. So there we need to manipulate the data. We need to check the data. We need to go ahead with
Okay.
the designing part of the graphs and charts on top of data and all. For that purpose, we just need to get the data in the format of relational database. Okay, so that is why uh, for the further classes, we'll be focusing on relational database only. NoSQL will not be learned over here. So it's just for your knowledge. Maybe in future you are integrating some databases. I think you are already aware. You have gone through DynamoDB in AWS. It's a
Yes.
NoSQL database. Yes. So you
Yes.
can see the prices also. If you just go ahead with the relational database, maybe you have launched some RDS, or you might have checked out DynamoDB as well. You can see DynamoDB's price is comparatively low than that of RDS value with the same size. Maybe
Hmm.
okay. So the size is also, the price is also less in case of NoSQL database instead of relational database because of this. But for data analytics purpose, we just need to choose relational database over there. So that's why we'll be focusing on relational database. Okay.
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 Let's get started with the. Okay. What is the plan for today's learning? Just quickly repeating. So relational database on top of relational database. As I mentioned yesterday, we need to store the data inside a database. So the data can be stored in form of table. So table is the basic unit of a database. Okay, and there should not be database. Tables only. If we just go ahead with some advanced topics as well, we can see based on those tables we can create some views, some materialized views, some store procedures. So those are, integrating those tables, we can create those kind of different database components. But the basic you need to be learned over here, it's simple, a particular table. If we learn table and all, the concept should be clear for everything. If we just go ahead with some advanced topics, then we can find the usage of views, materialized views, store procedures, synonyms, indexing, those kind of small concept of different topics of different database components. I'll be coming this thing in different slides. So today we'll be focusing on top of tables only. Within the table, how we can bring the table data is normalized format. Okay, so
Okay.
there are two terms called normalization and denormalization inside inside tables data. So
Hmm.
we need to verify whether a table is normalized or denormalized in nature. If it's denormalized, we need to store it in normal. We need to make it a normalized one. So there are two normalized form. One is called first normal form second is called second normal form. Obviously, second normal form is the preferable one when we are saving the data inside a database. Okay, I'll be coming how that can be converted from denormalized table to normalized table, and what is the purpose of doing that. Okay, there might have some purpose to do that. So what is the purpose
Hmm.
behind it? You can quickly learn it. And after learning of the same thing, we'll be having some concept on top of keys. That thing I have already provided yesterday's classes. I'll be just go through once more time because this is very much important. And the next session, we'll be using, we'll be emphasizing these things. We are creating some primary key in a table, then how to do that and why primary key is required. I already mentioned this, but I'll be just touching this thing once more time. After
Okay.
that, we'll be directly, I mean, we'll be going to the database side itself. So we'll be installing a database in our system. And from tomorrow onwards, on top of that database, we'll be creating tables. We'll be doing data manipulation on top of tables and all. So specifically, it should be languages we'll be learning. The language is called SQL or structured query language that I told yesterday to, I mean, uh, traverse anything to create any tables or anything on top of this database. Okay, so this is the plan. So when our database is set, tomorrow onwards we'll be going ahead with this languages part. So today I'll be giving you some link and some installation part, how to install it. It's very simple actually. You can download and install. No such hard and fast rule. Maybe they will be requiring some prerequisite softwares and all. So you can quickly check it. Okay. So
Okay.
those are the topic we should be learning today. And from tomorrow onwards, when the database is ready from our machines, so we should be going ahead with the hands-on part quickly. The hands-on is very simple to create a table, to update a table, to manipulate the data inside the tables. Those are the landing points inside the table. Those are the basic
Hmm.
one. Gradually, we'll be going ahead with some detailing part, some advanced levels of SQL languages and all. Maybe next day onwards, Monday, Tuesday and all. Okay.
Okay.
Okay. So data without normalization, everything that normalization part. Okay, let me start this thing with the bigger font of the Excel. So data with normalization, the thing I'll be representing in an Excel with the examples, how the data, what is denormalized table and how we can make it a normalized one. Okay, let me open the Excel. Yes, this is a Excel. So I just took this one for the reference for an example. This is the first. I stored this kind of data, student data, from a particular coaching institute. Okay, I collected the information there. So as you know that, there are four columns: student ID, student name, course ID, course fee. My quick question for this table, which is the primary key? I mean,
For this, yeah, for this is primary key is student ID,
correct. Because student ID should be unique. Maybe
unique.
student name can be same for a particular coaching center. Course ID can be same. Multiple student can learn the same courses. Okay. Let's go ahead with the topics once more time. Okay. Data without normalization. So this is an example that the data is not normalized in nature. So why the data is not normalized? Let me see the example why the data is not normalized over here. So we can check. The first criteria of data to be normalized is there should not be any duplicated records in a particular table. If the table consists duplication, then we can say the data is not normalized. This is the first
Okay.
criteria to detect whether the table is normalized or not. So you can see row number 3, this one. I'm just highlighting this part by yellow.
Hmm.
This part as well by yellow. Okay. So you can see those two rows are exactly duplicate. So
Hmm.
the particular admin forgot to change, or he might have mistaken over here. I mean, there is a mistake. He pushed the record once, he forgot, and he pushed the record once more time. So this is not normalized. And one more thing, to be normalized the table, I mean, simple, I mean, for the first normal form we need to achieve, then particular cell element cannot consist multiple value. Okay, so you can see this kind of cell, it's consisting multiple value. So particular student is learning two different course. It's A1 to A1. This is the course ID. Not sure what is the course name over here, but I'm just putting course IDs. And each of the course IDs is having the course fee just like this, 800, 300. Okay, so both of the things, this I mean this cell and this cell, they are consisting multiple values inside a single element. Same over here, same over here. I mean, this should be eliminated, no issue. So to make it a normalized one, what we should have to do? Okay, data normalization is the process of recognizing the data within a database so that users can utilize it to further queries and analysis. To make it a good one, to efficient one, we need to make the table normalized one. Even if we save the normalized table in the database, the particular spaces should be very minimal. So you might have checked while launching or spinning up a particular database or RDS specifically, we need to choose a particular memory size over there. So whatever data we are saving it, that can be, I mean, the memory will be utilized there. So if we store a particular table after normalizing it, it should give very, very small space inside that particular database. So our cost will be, I mean, that should be much more cost effective as well from costing purpose. So that is why for all the reason, the normalization thing should be appeared. So the first criteria should be duplication should be eliminated. If the table is normalized in nature, the results should be in smaller database. Since there is very less data, duplication or zero. Minimize or avoiding issues with data modification. If we are just going ahead with the data modification, then it should be much more easier. Just like you told me that student ID is the primary key. But if the duplicate is there, so you can, I told you yesterday, primary key cannot be duplicated.
Yes,
12
it should be
cannot be
unique.
duplicated. That's why I cannot mention that the student ID is the primary key over here. But I can definitely push it if this record is eliminated. Okay. So that is the reason. That's why we want to make the data the normalized one. It makes the query easier. The SQL query on top of the table, if we just do this thing, the query should be much more easier. The runtime of the query, I'm doing some query at the user interface, and at the backend, it's fetching the data from the database. It should be much more faster if the table is normalized in nature. Okay, so those are the reason we need to make a table a normalized one. So what are the different forms? First normal form. This is one, I mean, one step to do the normalized table, or a table to be normalized. Okay, so that I mentioned, each record should be unique. Those are the two rules actually. Each record should be unique. That means the duplication should be removed, and each cell should contain a single value. So this two is the basic criteria to make a table. To make the table, I mean, it should be consisting as a first normal form, 1NF. That is called first normal form. What is it actually? Let me go to the Excel. So I'm trying to eliminate this row first. Okay. So what should be the table structure? It should be this one. Okay. YOLO. I'm just updating this thing, or I'm doing a format pointer. Okay. Now I just deleted this row and my table structure is this. Now I can say perfectly student ID is the primary key for that table. For this instance only, I have done one thing. Now my next thing is to remove multiple elements in a single, multiple data in a single data element should be removed. Okay. For that thing, what I have to do, just go to this example. I have split each of the elements. Suppose the first element is first row is fine. 11 Pankaj A11 500 is fine.
Excel
Nah,
Excel
yeah.
बहुत मजा आता है
The second
Excel
row, you can see there are
SQL નું
two
બધું દેખાડે છે.
SQL
single element.
SQL ના દિવસો ગયા you know that
A1 to
That's all
A1.
AI now you know that right
Hmm?
SQL you don't need to learn how to query stuff that's all AI you know that right
Part of it noise is coming. Yeah, thanks. So for this course ID, you can see there are two elements over here. So I have splitted those two elements into different rows. So 12 Sonu A1 to 800. Okay, and the next element has been pushed to next row. So we have created the new records with this one. But the record is not duplicated. The duplication can be there for student ID and student name for different courses they are learning. Okay. So just I try to say a particular student is learning multiple courses. Then there must be two entries for that particular record. I mean, particular student. Okay. Same kind of stuffs I have done for Raj. You can see this one. Okay. So we created two new rows, this one and this one. Now, for this instance, I can tell the table is in first normal form or 1NF. Okay. Any doubt, Parth?
No.
Okay. Now my question is this the primary key now? Student ID is the primary key now
No, not yet. Still
because
not.
12 is represented twice. Student ID
Yes.
is two times. For this instance, can I see the combination of student ID and course ID can be a primary key? A student, a particular course. Student is learning a particular course from a coaching center. That cannot be repeated because I should not enter multiple things. A student learning, suppose he is learning history. So as we are in first normal form, this thing will not be repetitive. Student, so I can say the combination of student ID and course ID for these cases is primary key. So this is the concept of a composite key. I'll be coming to this topic again in the next slides. So just to let you know, in this instance, okay, primary key, this is not a concept that a particular single column can be a primary key. Okay. For this scenario, as I mentioned, student ID is the primary key. And over this scenario, as we have splitted these things for multiple rows, 12 is duplicated. So there we can see student ID and course ID. The combination of these two columns is a primary key. So primary key can be a composite key. Okay, composite key means more than one columns can be represented as a key element. Okay, we can use a hash function on top of that, MD5 functions on top of these two columns and create a derived columns which should be unique. Suppose I'm just doing a concatenation function on top of student ID and course ID. And you can see that is a unique key. Okay, so that is why I want to mean, let me show you. I'm just doing a concat operation on top of that. Okay, so this thing is unique in nature. You can see because one student, one course cannot be repeated over here. So this we can say this is a primary key. What we are doing over here, we are just combining these two columns. Rather doing the combination by this way, we can directly tell that we can go ahead with the composite key concept where multiple columns, there can be 2, 3, 4, 5. combination of multiple columns can be a key or a primary key, and that is called a composite key. Okay, fine. So now we can say this particular table is in first normal form, 1NF. Okay, we achieved that thing. Now the next thing is we need to achieve the particular table in second normal form. So what is second normal form and what is the criteria to do it? In second normal form, the first criteria should be the particular table should be having, or it should be meeting the concept, it should be in first normal form. Okay, if the table is not in first normal form, we cannot go to the second normal form, obviously. So this should be the first point. First normal form, it's there in first normal form in our example. The next topic, we need to remove the partial dependency between the key elements with the other columns. Okay, this is very important concept, and this is very, I mean, the concept is, we need to clear this concept very quickly. Okay, let me show you. I'm just going to directly to the Excel sheet. So over there, for this instance, our primary key is student, combination of student ID and course ID column. Okay, and we have to check if there is any such column who is not dependent, or which particular column is not dependent on the primary key. Can say student name is definitely dependent on this primary key concept. Course ID is also dependent on that one, but can say course fee is not dependent on student ID actually. Course fee is dependent on course ID, only course ID. That's why we can remove this column from here. If we have partial dependency, we can remove that column from the data table, and we can just create a separate table if we have a single dependency. Suppose I want to say that the course fee is a single dependency on course ID only. So I have removed this particular data set and keep it over here. If we just keep the thing over here, we can see there are duplicates as well. Course ID A11500, again course ID A11500. That was been mentioned over here because two students are learning same courses. But when we are keeping course ID versus course fee, to make it a first normal form, we need to remove the duplicates one. That is why we just mentioned the relationship should be there. What course ID is there and how much fees will be taking from the student. So that is the concept. We removed A11 from here, A14 from here, and only those are the phrase columns or phrase records. Okay. So we have eliminated these stuffs from here and create this thing here and remove the duplicates as well. And the rest of the stuffs, this thing I have mentioned over here. Okay. If any time I need to check how many price Pankaj need to pay to the coaching institution, there is the concept of relational database. If you can just recall the particular dependency or the relationship between table, there is a diagram. Yesterday's session we were with the diagram part. So there we checked the dependency of order table and product table. Similar kind of stuff. Here we can say this is student table, this is the course table. So there is a common column course ID between each of the table. So we can set up easy relationship between course ID. By course ID, we can join these two table and fetch the course fee information for each of the student. Okay. There is no, I mean, it's very simple. It's not a hard one. Okay. So that is why in relational database, we need to normalize the table and save the table in database in this way. But we are splitting up the data between these tables, but we can set up quick relationship because we have common columns. Just like course ID. Suppose I want to make how much Sonu have to pay. Okay, Sonu has to pay. I need to check which course ID is involved with Sonu. A1 to A13. Let me check over here. A1 to A13. So the summation of these records should be payable by Sonu. This thing in Excel we have using only 4 to 5 records, but in database there should be, I mean, thousands of records, millions of records. We cannot calculate it by this way. So there we need to do the SQL query, joining operations and all. This is the concept of relational database. So now my table, this thing, there is no partial dependency. There is no partial dependency over here. The combination of these two things, we can say it's in second normal form. Okay, so we achieved second normal form of the particular table's data. Now, is there any doubt or any stuck point part? Because the concept we need to clear.
Yeah. So
Concept.
to get the to get the I mean, first we made a composite primary key to get the first normal form, right? And now
Yeah,
to get
it's not
the
compulsory. It's not compulsory. It can be first normal. I mean, a composite key might be there, but for this example, it's a composite key. Suppose we have this table. Let me show you. I'm giving another exercise. I mean, example. We have only one data.
Hmm.
Okay. Let me show you in a different sheet. So we have one data. Maybe in the beginning itself, we have one data.
I mean, in short, like for data to be normalized, I mean, for data to be 1F, first normalize, it should be like normalized. There should be no duplicates, nothing like that,
Correct,
right?
correct. Yeah, that's correct. Yeah, data should be, I mean, for first normal form, the data should not be duplicated, and one cell element cannot consist of multiple data. So that
Multiple
we
data.
have done.
Okay.
For this thing, as there are duplicate, I mean, multiple elements for a single, I mean, single cell. That is why we have split this thing up in a new record. While doing that thing, that's why student ID earlier it was the primary key, but after doing that stuff, student ID is not a primary key anymore in this table. So there, to detect the what is the primary key for this table's instance, then we can say student ID and course ID combination can be the primary key, but it's not mandatory. Uh, when the data is there in first normal form, there should be composite key as the primary key only. It should be possible only when there are multiple elements and we are splitting them up in multiple rows. Then we can say the composite key is the primary key at that point of time. Otherwise, it should not be a composite key. Okay. It's a subset of event that you mentioned.
Okay.
Okay. And the second normal form, we need to check each of the columns dependency with the primary key. So there we just detect course fee is not directly dependent on student ID. It's only dependent on the course ID. And the other thing, student name, student ID, course ID, the other thing, if there are other columns as well, those are directly dependent on the composite key or the primary key of this
What's
instance.
up?
That is why we split this thing up over here and this thing over here. So you're storing the data in this format, this two tables format, and we are splitting this up. Not we are permanently splitting this up. When we need to combine this thing,
Freelancer.
we can quickly combine this by using
Freelancer.
SQL joins and all.
India.
Okay.
ये मन नहीं खबर. तुम्हारे
Okay. So this is how we can achieve second normal form and we can store the data inside the database. Hope the concept is clear. Okay. So moving to this next slide, I already covered this thing in yesterday's session. The concept of primary key, the particular column which is unique in nature. Composite key, a set of columns used to uniquely identify the particular row in the table. So a composite key can be a primary key as well. Composite key can be a foreign key as well. Okay, foreign key, a key that references the primary key of another table. So I mentioned this thing and this example in yesterday's session. So particular table, in a particular table, okay, here I can also show you. So in the course table, course ID is the primary key, and the same course ID, only the course ID column is a foreign key for the student table as well.
Yes.
Okay, and we can set relationship between this primary key and this foreign key to combine the data when it's required. Okay, as the main, I
Yeah.
mean but the better example I have given to you in yesterday session with particular order, customer, those kind of tables,
Mm.
product.
Yes. So,
Okay,
Swapnik, I got the first normalized form, and for the second normalized form, the data should be in one NF. Also, we need to remove the columns which has partial dependencies, right?
correct. Yes.
Okay.
Okay.
So in case like, right now, because we had the composite primary key, but when the key is not composite, it's just primary key with one column, right? So in that case, like I think there shouldn't be any other column with partial dependencies, right? Because there'll be the primary key in that case will be just one column.
No, primary key can be composite key. Over here, I
Yeah.
can also, this is not a primary key. I mean, student ID is
Hmm.
not only the primary key. The combination of course ID and student ID is the primary key. So better I can represent the table in this manner. Let me show you. Let me copy the
No,
entire
okay.
table.
I got this one, like this particular
Okay,
example, I got it. But what I'm
okay,
saying is that let's take an example which has a primary key, is not composite. It's primary key with just one column. It's unique
okay, okay,
with one column. So
okay.
in that case, like all other columns apart from primary key
Yeah,
will have all the dependencies on the primary key, right? In that
correct.
case,
Exactly.
in that case, we won't have any other column with partial dependencies, because in that case we are directly relating to just one primary key, one column.
Correct. Exactly. Yes.
Okay.
If we have any partial dependency, we have to remove this dependency. We need to create a separate table for that.
Okay.
Okay. If we store this kind of data in database, it should take much more space than storing this database. Here, the example is only 6 row, 7 row is there. That is why we can say that why this is there is two table. It's taking larger space. But while storing, I mean, for the physical, I mean, for the practical scenarios and all, there might be thousands of records, millions of records are there. So for this scenario, we can tell. Suppose when we are removing partial dependency, this particular table is very much small. Okay. So that time we can definitely say the data is much more efficient to store in the database as well. When we are in second normal form or the normalized tables as well. We'll be coming to
Okay.
some concept in business intelligence as well. Let me tell this thing now. So when the tables are being used for the reporting layer, okay, when our tables are ready, when the tables are used for reporting layer, we'll be setting up OLAP. This is the concept OLAP. I'll be telling all the things in details.
This is online like analytical
Online
processing, right?
analytic processing, correct. When we need to do this thing, we need to
This is
convert, we need to join those tables again to bring back all columns into the single table. So OLAP
okay.
database or tables are denormalized in nature, but
Hmm.
that has the usefulness when we'll be creating graphs, charts to identify the business hidden trends, patterns, and all. Suppose we
Hmm.
are investing in mutual fund, we can check there are I mean the line charts are been drawn over here. I mean multiple things are been called because without this chart we cannot able to see how much growth was there, what is the slope in last 5 months and all. So this kind of stuff when we are creating those charts and graphs, we bring back all the columns in a single table. So there
Okay.
we are making the normalized table to denormalized again. So this is an example of OLAP analysis, online analytical processing system. We are bringing back all the tables inside a single tables. So that is OLAP. So there is no way, no other way. But as we are removing the duplicates from that time, So might be duplicates will be removed. Might be the particular cell element, that concept will be removed. So rather we can say OLAP should be in first normal form. So
Yeah,
OLAP,
that's what I was going to say. Yeah, true.
correct.
So data will be in 1NF in case when we are doing OLAP.
Yeah, correct. So while doing the OLAP table is not fully normalized. There we need to bring back all the columns. Otherwise, on top of that, we cannot create the charts and graphs properly. Okay, we need a single table to be built, and on top of that, our charts and graphs and all kind of visualization techniques can be done on top of that. Okay. Okay, moving to the next topic. Okay, now it's time for the practical one. So let's install a database in our system. Is there any database installed in your system for any practical purpose?
Not sure.
Okay, we can install a database locally at our system. So we can, okay, there are various database available. Let me show you. Okay, what is database as well? So database is the repository where we will be creating the tables and all. So this kind of relational database can set up in our machine, uh, just like Excel. So we can, just like this columnar structures and all these kind of things, we can easily show to you over here.
Okay.
And the same thing I'll be coming again. So while doing a practical scenario, a business things, I'm checking the business data and all. So there should be millions of record, even billions of records should be there for a particular table. It's not possible to store everything in a Excel sheet. Even if I just open this kind of Excel sheet having large data set, you can see the Excel sheet will be hanged. Okay. So that is why the database concept is there. So you might say that we can store the same thing in Microsoft Access or over here in the tabular structures with multiple sheets, elements, and all. So there we can create easy data. But if you just go ahead with database demos and all, you can quickly say yes, database is much more efficient to store the tables over there. Okay. So there are lots
But
of data
yeah,
available. Yeah. Okay.
but isn't the SQL a type of database something?
SQL is the language.
It's a language. Okay,
Yeah.
because I got confused because usually they say SQL database together, right?
Yeah,
Most of the
SQL
times
database. Yeah,
people.
yeah. You are telling SQL means MySQL. Okay, let me show you the next. You might have seen this one. Especially
Okay.
SQL is the language. It's called structured query language.
Query
On top
language.
of SQL tables,
Hmm.
on top of SQL tables, uh, SQL tables means the relational database tables to fetch the data, to retrieve any kind of data, to manipulate any data. We need to put the query languages. Just I
Hmm.
mentioned in yesterday's example. I think you mean to say this one. The
Yes.
database name is MySQL.
So whatever
Even-
queries we will write,
Correct,
it will be in SQL, right? SQL.
correct. Yes, exactly. So
And
there is
that okay,
database
okay.
available. Yeah, tell me.
Hmm.
Sorry.
So whatever query we write, it will be on SQL language, and that query will find our solution or whatever we want from this whatever database we are using, right?
Correct. So
Okay.
first of all, I want to say SQL query is almost same for each of the databases,
Hmm.
and but for each of the databases there is a few syntactic difference. Specifically, some inbuilt functions are there for each of the
Hmm.
databases. Uh, their functionality is same, but their representation, maybe the coding part is a bit different. You learned the SQL thing in top of one particular database called Oracle, suppose. Okay.
Hmm.
But if you have the functional knowledge on top of that, it's 95% same to do the same query for all the database itself. Okay, suppose you learn the tutorial on top of MySQL database. So the syntax is 98% same. Suppose you have got a job on top of Oracle database or Microsoft
Hmm.
SQL Server. This is a Microsoft data. I mean, Microsoft owning tool of database. It's called Microsoft SQL Server.
SQL Server.
Okay, there is Teradata. One is database. One database called Postgres. You might have a Postgres. I think you worked in AWS, so you
AWS.
might have no Postgres.
Postgres
You might have
and
heard about Redshift.
Redshift. Yes.
Redshift. Yes, there are lots of databases available in the market. As of now, there are more than 50 databases are available. Okay, so but each of them has a specific criteria. Obviously, there's a Snowflake database. I have found Snowflake is very much nowadays. You can see Snowflake is a cloud-based database and it's heavily used in enterprises now onwards. It started. It's a very new and hot topic in the market to use a Snowflake database. But the query is same. The backend architecture is bit different. So that is why
Okay.
there are some extra additional feature, especially the costing things. I'm not coming to the costing things now. We are learning the data, but for you, as you are the data architect, I mean, the particular system architect in cloud. So you, I mean, when you will be joining in a position in a company for data, you might have joined as a data architect there. Okay, so there maybe project requirements are coming. You need to analyze what are the components needs to be used. Suppose you join a particular project in scratch, from a scratch. So you are taking the business knowledge from the user, and you have the requirements. You need to create the architecture. What are the different
Okay.
components been used or spin up from AWS? You are creating the pipelines, and you need to design the things. What kind of AWS components you need to spin up, and you need to also think in your mind of what should be the database you need to spin up there. You have the purpose. This is the purpose. Your purpose is to store a relational database for analytical purpose. There you need to choose Redshift or just like any other thing. You should not be choosing RDS for that instance. Okay.
Yeah.
So you need to choose what, I mean, you need to think what particular purpose you need to use that particular
Yeah.
component and all. So that is why a particular architect will be choosing which is the particular database they need to work in the project, and based on that the project should be starting or the query should be triggered over there for the database. For our courses we'll be choosing MySQL over here because
Okay.
this is very soft, I mean a very light software to be installed in our system, and it's
I have
open.
this. I checked just now on my computer. I have the MySQL shell window, like I in my
Okay,
search bar. When I search for
okay,
MySQL, I think I downloaded like before, like I don't know, before a few days when I was learning this AWS course. So I think
okay,
at that time I downloaded.
okay, no issue. Then it is very fine. Okay, so I can also say give you the link as well. The link I have
Okay.
mentioned over here. So this is for every, I mean, other persons as well. If they do not have this, so just go with this installer part, and okay, this is for others as well. Who is not installed, they can watch the recording. So this is the link to install it over there. Download the second option, the, I mean, the bigger file, 331 MB. Download it and install it. The installation is very simple. While installing, you can face one particular challenge. That particular software based on Microsoft Visual C++. I mean, it should be installed as a basic prerequisite. But particular software should be available for any Windows systems actually. But if it is not, then you just need to install this thing as well. So they, I mean, while doing the installation, they will be telling you that stuff. So it's not very hard. They will be telling you that this is a prerequisite. You need to install it quickly to proceed further with the installation. So
Okay.
there you need to install. So when the installation is completed, okay, now I'm just going to this topic. MySQL is there. So
Yeah, I have
MySQL
this MySQL shell SHELL. I
Shell,
have this
we
one.
can do this thing on top of Shell. Shell is a, I mean, actually Linux based thing. So
Okay.
shell command we need to put over there. But I'll be preferring to have a user interface kind of stuff. So it's MySQL Workbench.
I think I have a setup.
Okay,
Uh,
after finishing this, let me see your system. Okay, so
okay.
just like it should be coming in this manner. This is my database. Okay, one more thing. While installing that particular database, uh, particular password you need to put at the beginning or beginning of the configuration setup or installation part. The password will be used for each time you will be logging into the database.
Mm.
So I'm logging into this database, just double click on it. It will be asking for the password. So that password will be required for every day when you will be logging into the database. Okay. So now
Yeah.
set database.
Okay. No problem. Like I was able to open the same window as yours.
Okay, then there'll be no issue. Okay, in the left hand panel, those are all database schemas. Okay, those are called database schemas. Okay, for this particular tab in a database, there are two kind of people can work. One is our database engineers, just like us, and another people can work. They're called DBAs, database administrators. Okay,
Mm.
so as you are aware of this cloud platform as well part, so there we can see. I mean now onwards, I mean they are giving us the control. The project are going to such a way that even the database engineers can have the access to the AWS console. Even they can control the particular admin related part as well. They can control the IAM access management part. They can control the particular backend memories and all threshold values. Everything they can control. They're doing the database part as well. They can be DBAs as well. But for the ideal scenario, there should be two different teams. One team should be managing the database. I mean, they will not check the data, rather, they will control the who are using the data, they will be control their access. Okay. And the database engineers, they will be checking into data. So those are different database schemas. Each of the database schema, we can store tables for each subject areas. Suppose this one is for test practice. So I'll be testing my side. I'll be doing some trial and error inside that schema database schemas. Okay. For our learning purpose in Teradata, I'll be choosing that one. I created a schema called Teradata underscore training. So over there, I can do my exercises over here. Okay, suppose I'm doing some project, I can create my tables over here in the world database. So those are called database schemas. You can create your own schemas. Just right click on any one. There is an option of create schema. Okay. So you can do this thing by this UI, or you can also put a command at the query window that create schema name. Okay, this is also possible. Just put the new schema name over here. Suppose the schema SCHEMA underscore 123. Apply it. You can see in the backend it will be triggered. This is the query, a structured query. I'm not starting the structured query today. It will be starting from tomorrow onwards. So just to let you know, when we'll be doing the UI side as well in the backend, they will be triggering this kind of query as well. So create schema name. If I just apply it, close it, just refresh this pane, you can see the new schema has appeared over here, schema underscore 123. You can delete the schema from here as well. Drop schema. Okay. So this is how, this is where we are storing the tables. So first of all, we need to check whether we have any database schemas available over here, or for your purpose, you can create a new schema for our Teradata training purpose.
Mhm.
So when schema is available, okay, this is the database schema. There is a particular topic I mentioned over here. Go ahead with start creating the tables inside the particular schema. You can see there is those kind of things, tables, views. Okay, I told you, I mean, I was telling earlier that table is the most important thing inside a database, and the unit, the basic unit of database is called a table. But
Mm.
apart from table, there can be other component as well. Those can be database views, store procedures, different functions. Okay, I have mentioned some more topics as well. Tables is the basic unit storage. Those are all the things are called database objects. Each of them are a
Mm.
single object. So table is the most basic and most important thing. Apart from table, we have view, we have sequence, we have index, we have synonym. Those are the other database objects. Those are also available inside the database. As of now, we'll be focusing on only table. So when we have quite experience how to handle tables and all, then we can go ahead with the other object. Okay.
Mm.
Okay. So that's all for today's session. Okay. Do you want to share your screen to show your
Yeah,
data?
yeah,
Okay. I'm just
sure.
stop sharing my screen. Okay. You can now start sharing yours.